When we are implementing REST services, we usually have a lot of concerns. One of them can be resilience, another one can be robustness, and another one can be how our REST services are going to respond in face of adversity. We end up wanting to implement some kind of automated testing that will allow us to test the behavior of all our infrastructure and how the different services communicate with each other. There are multiple solutions for this. We sometimes use something called chain tests, and that is simply implementing our own client for our own services and see how that behaves with different requests made to the different microservices. Another one can be using Cypress, because Cypress does have good support for testing REST endpoints. However, Cypress is more designed for the front end. And so another thing that we can do is implement our automated testing with curl or with wget. And here we would have to rely on some kind of shell scripting, maybe some bash, some sh file, or maybe some batch file for Windows systems. And none of these solutions actually appear to be a perfect solution ever, until we come across things like Postman or Insomnia. These are tools that have a graphic user interface that allow us to automate our requests. We can, instead of programming our automated tests, we can now configure them, which usually provide us with a lot of heavy lifting needed to create these automated tests. I have used tools like these in the past, and with them I was able to test my services manually. But I never really got to automate anything with Postman. Another thing that I started using often, like many of you probably already have after Postman, is Swagger, and to use the OpenAPI specification and make these tests via an embedded interface in our application. And then I found out recently about Insomnia. And Insomnia is a tool quite like Postman, and I was able to use it in one of my projects. If you have been following this channel, you already know by now that I have created a project called Wildlife Safety Monitor. In this project, I've explored Kuma and other open source projects for Kong. When I created this application, I created an array of services, and I created an interaction between them. And the idea was to send signals from an albatross called Piquinho, and it would send its location to the listener service. The listener service would then relay that data to the collector service, and then the aggregator will be our access point for the different data that would be calculated, or even the raw data in the database. So I thought, now that I want to explore how Insomnia works, would I be able to create an automated testing for my application that would precisely test that data flow from the listener all the way up to the collector? One important thing to know about Insomnia is that there are two versions. One is open source, and the other one has nothing to do with this series of videos. So what I wanted to do is to make sure that I would keep the project open source, and that I would only use the open source tooling available regarding Insomnia. And this is what this series is about: how I have created an automated testing system using Insomnia and its open source capabilities. Before we dive into our example, it is important that we make sure that we have in our local machine two command line applications installed. One of them is Kind and the other one is kubectl. We will need Kind to install our registry, and we will need kubectl to perform operations in our cluster. Now, to do that, I have created a script, and this is called install cluster apps Linux. And I will start it right now, and then I will go through the script with you to see what it does. If we go here into the actual shell script, we can see that the first thing that it does is to install the latest version of Kind. Then it will install a few command line application utilities like apt transport https, CA certificates, curl, and gpg. This is in order to be able to install in our local apt repositories the keys necessary to install certain specific versions of different command line applications, namely, for this case, only Kubernetes. And what we do afterwards, we will read out of this file, out of this API, the latest LTS version of Kubernetes, and then use that in our commands to install the keys necessary for Kubernetes, and then finally ending it all with an apt update and a specific installation of kubectl. But this, of course, isn't enough. We also need to start our cluster. And to do that, I have also created a script, a makefile script that is located over here, and it is called Kubernetes init. And before I continue explaining what this script does, let's first start it, because it takes a while to start our whole cluster, and therefore I will just call it like this, and there. So now the script is running. We will have our cluster running in a few minutes. And in the meantime, let's see what it does. The first thing that it does is clean up our machine from any previous runs of our code. What it is doing here is simply removing the configuration. Then it moves on to remove the cache. Then it moves on to remove all the clusters related to kind. In the second phase of this script, we call B. And B is short for build. And what it does is simply build all our Gradle submodules. In the third phase of this script, we create our cluster, and this is simply kind calling create cluster with the name WLSM mesh zone, and then using kubectl to show us the details of the newly created cluster. In the fourth phase, we are creating a local registry. This is where we are going to push our images needed to start our containers in our Kubernetes cluster. So we start the registry, and we call this script kind with registry. This script is available in Kind's own website, and anyone can download it and use it. Once that registry has started, we can finally create and push our images. And so in this case, we are going to go through every single module and then push every single image to the local registry. And at this point, you may ask, why do we need a local registry? I'm trying to avoid, in this case, to use a Docker Hub registry, therefore making the project completely independent and avoid using any cloud services at this point and just using our local machine for it. In this sixth phase, we are applying all our different Kubernetes template files, and we are going to loop through the different modules that we have. And so important to highlight here is the kubectl apply file by force. This, of course, is for a demo. Force is not advised to be used, and with this force command, we ensure that in our demo project, we override any possible pre-existing configuration in our Kubernetes cluster. At this point, we have everything starting up. We only need to wait until our clusters are ready, and for that, I have created a script that simply waits for the clusters to be ready. So this means that when we check out the states of the pods, they all need to be completed. And that's exactly what this WLSM wait script does, where we can have a look at right over here. And as we can see in our shell script, we can see that we are only waiting for our containers to be ready. This is a check for all of the containers, so all of them need to already be running before this script stops blocking the execution. And that means that at this point, everything has run successfully, and we see that all containers in all pods are running and ready. So this means that our cluster is ready for testing. But before we start testing our cluster, we need to open the ports. And for that, I have another script in the make file, and that is called open all ports. And this will just activate port forwarding in all of the critical ports that we want to use for our cluster. These are the 8080 for the listener. Then we've got the 8081 for the collector. Then we need the 8082 for the aggregator, and finally the one for the database deployment. The last one is for Kuma, but we are not using Kuma here, so this will fail when we run, but that's not a problem because the execution will continue, and all we want to do is basically to be able to access our cluster from the outside of the cluster. So therefore, I will just start the open all ports makefile script, and now we see here in the command line that forwarding has been activated. So this means that we now have all our containers available, they are all running, and we are ready to perform tests. But before I dive further into testing, let's go through our application once more, but in this case zooming in at how everything is set up together. And the first step is probably to have a look at the database. So let's do that. In the database, we have seen that there's a lot of different tables, and they define what an animal is and what the genus and species they belong to. But the most important thing is the animal itself. So let's read the table and see what's in there. When we read this table, we find the two animals that we've mentioned in the beginning of this series. The one is Pequeno and the other one is Test Pequeno. So the first ID, if you recall, is created randomly, and the second one is fixed. Let's have a look at the first one, which is with this ID. So when we start a database, this row is created. It has a species ID, pretty much the same as the second animal that we have created. But let's now copy this ID and use it in our test request. And before we start out with Insomnia, let's first see how this behaves with our scratchpads in IntelliJ. I have one here called test requests, and we can now make a request to our listener. So let me put first the ID over here. We have latitude and longitude. We can change these numbers at will. We can, for example, put one like this and then put like this. So we've got 3, 4, 5, 5, 6. For latitude and longitude, we have 1, 2, 3, 1, 2, 4. These are not valid latitude and longitude numbers, but these are just numbers that are acceptable to insert in our database. This post request represents the sending of the signal from the sensor and giving us the location of our animal. So let's do the post. And we can see now that the request has gone through. We can see that our request has gone through, but what exactly happened to our request? Let's have a look at the code and see what it does. If we go to the listener, we go here to source, main, Java, and go to our controller, we can see that this is a traditionally implemented Spring application where we have a post mapping for a create function, which is called send animal location, and that returns the animal location that has been put into the database. But there is no database in this case. What we call here is a persist method from the listener service that will add an animal to the cache, and then it will post it to our collector service that is located right over here in this URL that you can see over here at the top. The collector is located over here, and this is the source code for it. And in the controller, we can see that we've got another post mapping for animals, and it's called listen animal location, and it has a request body that matches the contract of the listener service and will now try to persist this value. And what it does, it calls this persist method, which will then use this persist method that will then publish our event to our application event publisher. So this means that when we publish this event, it will be eventually handled by an event handler. And this is located over here. It's called the event handler service, which contains an event listener for the animal location event that we have sent via the event publisher. And this is finally where we persist our data to the database. This is where the location of the animal gets persisted into our animal location table. So let's now perform our request to see if our location gets to the database. So let's go back to our Scratchpad, and that is located over here. As we know, test request, as we have seen before, and it's going to make a post request to the create endpoint that will allow us to give in the actual location of the sensor. Let's double check the ID of the animal. This one, no, let's not do that. Yeah. So let's now perform our request. If I press play here, I will see that it will take a while to get the request done, but we will get a 200. A 200 in this case, as we have seen before, means that the data went through successfully via the listener through to the collector, and the collector has sent the event via an event publisher to where we then handle this event in an event handler. And finally, at that point, we persist our data to the database. If we have a 200 at this point, we should already be able to see the location of Pequeno. Let's have a look in the database if that is true or not. If we check on animal location, we see that we have one location there. And let's double check with our request if this makes sense. If we look at the latitude and longitude, we see that latitude has 3, 4, 5, 5, 6. Let's see if that matches with our request, 3, 4, 5, 5, 6. Then the longitude we need to find in the database 1, 2, 3, 1, 2, 4. And what do we have in the database? 1, 2, 3, 1, 2, 4. And the animal ID matches the one we see in the test requests. And of course, animal location gets its own ID. Let's send another location just to make sure that we are doing this correctly. And let's say that the location is the same and we put a 0. Of course, these are not valid values for latitude and longitude. This is just for our project. Let's post it again. And if we look at the animal location, we see another location there. What did we just do at this point? We have tested a successful case from the listener to the collector to the database. 3 services are being checked right over here. Another thing that we could potentially do is go over to the aggregator service And in the aggregator service, we will find two controllers that will provide us with helpful endpoints. The animal controller has an endpoint that is a get mapping of all the animals located in our database. This is implemented with Webflux, and if we go through the whole chain, we can see that the service simply makes a call to find all in our animal repository database. And the animal repository is simply a repository that will look into the table animal in our database using Java records. Let's have a look at what we have in the database for this point. We've got Pequeno and test Pequeno. So if we make this request, we are expected to find at least 2 animals when we perform it. And for that, let's simply map this to our Scratchpad and then simply perform a GET request to that endpoint. And we should be able to see here the 2 animals. And that's exactly what we have. We've got Pequeno and we've got test Pequeno. But this isn't the only endpoint that we have available for the aggregator. We also have here the location controller, which is important because here we can also see the location of our animals. And for that, we've got this endpoint, which gets us all the locations of the animals available. Remember that the aggregator service is meant to be a read-only service that we can use to read our data, whatever that data may be. And at this point, it only reads data. It doesn't perform calculations yet. So we can do the same and pass this request to our Scratchpad and there perform the location request, which should give us now 2 locations of Pequeno, which are these 2. The one we put before and the second location with the 0 behind it. So this gets an idea of what we are willing to test and what do we want to test with this architecture. It is simple on one hand because it's very easy to understand, but on the other hand, there are lots of moving parts over here. And of course, if we want to see if this is going to work in a production environment, then we need something more robust to test it, not just someone manually making these requests in the Scratchpad and checking if everything is okay with our application. Implementing all of this stuff with curl or wget requests would be fairly cumbersome and difficult to maintain. As we have seen already in the installation scripts, this is something that is very easy to provide easy shell scripting for the installation of command line applications. But when it comes to testing, it becomes something completely different with a much higher level of complexity. And this is the point where we can choose to make our own clients that will check over the code, and this is something that usually is called chain tests, and that will also add another layer of complexity to everything we are trying to test for. And because these are only backend services, using Cypress is probably not a good idea. However, their support for REST services endpoint testing is actually quite good. And this is where we begin to think about alternatives like Postman or Insomnia or any other alternative. But in this series, we are going to talk about Insomnia. So let's look at it right now. If I open Insomnia, we then see this dashboard with all of the different stuff that we can configure in Insomnia. This is already pre-configured. These 3 different documents are already pre-configured. But before we dive into them, what we are going to do right now is to see some aspects of Insomnia. How can we create document files that we can use in our automated testing? To be able to start with Insomnia, we first need to install it, of course, and for that I have created scripts. These shell scripts are located in a specific folder in our project called WLSM Insomnia Test. And if we go inside of it, we will see inside Insomnia the install Inso Linux and install Insomnia Linux. These are scripts that are going to be used by our GitHub pipelines to install these 2 programs. Now, at this point, you're probably wondering, why do we have 2 different programs? Insomnia is a desktop application that we can use to configure our tests and to configure our requests. Much like if you are used to Postman, it's kind of like that. And if you haven't used any tools like this, then this video is great for you because I will go through that as well. And Inso is just a short for Insomnia, and it's just a command line application that has features related to Insomnia. One of them is to be able to start our tests in an automated way. The install Insomnia Linux is made specifically in this case for Ubuntu, and it will install via its Debian package version. So if you have an alternative, please look at their website to find out the way to install for your operating system. And let me know again in the comments if you have any problems with installing this. The inso command line application installation is also done via this shell script that I have also created, and this installation is made on the basis of a tar.xz file available in their releases section of their GitHub repo. These two shell scripts are created from the shell scripts that are already available on their website or on GitHub. Make sure to look for them if this is something that will not work on your machine, if you see that this is something that is not compatible with your operating system. Once you've got Inso and Insomnia installed, it's time to run Insomnia, which is what we just saw over here. And the starting point for how we design test projects in Insomnia is most likely the OpenAPI specification of your endpoint. If you are using IntelliJ, there's a great thing that you can do to get this file, and that is if you go to the endpoint that you want, which in our case is the listener service endpoint, we can then go over to the project, which is located over here. And if we get to the controller, and we get over here, we can generate the OpenAPI draft for this endpoint. And the great thing is that it will create a file already ready for us, and it will also generate a kind of a graphic user interface that we can use already. The only thing that it doesn't do really well is the detection of the URL, because it doesn't know at this point which URL are we willing to use for this GUI that it generates. And so what we can do is go to our test requests file, where we have already created a post request for it, and here extract the endpoint, which will be this one. So this is our root endpoint, and the create endpoint will be defined over here. With this definition file, we are ready to create our first draft of our document inside Insomnia. So let's copy this, and let's create a new document next to the existing ones that we are going to have a look at further down the line. And in this case, we just press create, and then we do an import, and then we do clipboard, and without the need to press any other key, we just do a scan. And what it does, it checks and validates whatever we have in our clipboard, and it will create a workspace, 2 requests, and 2 environments with 0 cookie jars. Let's see what happens. Now we have created a new document, and this document is this one over here. We have just created our first draft for our document definition for our tests. If we do a get info, for example, right now with the application running, we will find that this is listener service version 1. So that means that Insomnia is already able to communicate with our endpoints. If we try, for example, to send information about the sensor location, at this point we can try it out and simply send a payload where the latitude and longitude are 0, but the animal is the one we need. And this one will be Pequeno. And therefore we can go here to the database and get its ID, and then go over here, execute, and then we see that it executes correctly. And now we would expect to find a location of 00 in our database. Let's see if that's the case. Check animal location, and we see that we've got latitude and longitude 0. The location of the animal is there now, and that means that Insomnia is now able also to send sensor location data to our REST services. This is great, but this is still not the test. For that, we still need to define collections. And let's do that right now. If we go over here to spec and click on this dented wheel, we can then generate a collection. And what it does, it goes straight into the collection tab, and there we will find our requests, post and get. This is where this starts to get very interesting. We will find that there is a warning here, and it says that attempted to output null of undefined variable. There is a base URL already created for us that now Insomnia is requesting us to define it. And we can do that in manage environments. Right over here, we can open it, and we can define in the base environment, for example, our base URL to be the one we have mentioned before, which will be from the test request, this one, and just up to listener. So this is our base URL. We need to make sure that base URL is double quoted. This is the only way that this JSON file will be interpreted. So if we close this one and now run our get, we should be getting the services version in our response, which is exactly what we see here. But get info is just a simple get request. If we make a post request, then we will find that our body is still filled with just string as the first example, and latitude and longitude still with 0 as well. Here we can also add the ID of the animal we are testing. In this case it is Pequeno once again, and then here we can add it over here, and then we can send our request. We have sent a new location, which means that if we go to our database, we are able to see that there's another location added with latitude and longitude set to 0. This is great. This is where Insomnia starts to get really interesting. Looking at this, we see latitude and longitude with 2 different values, which in this case are both set to 0. And we can assume that we can change these values to something like this and something like this. And if we send it through the wire, we get latitude and longitude with different values. We can, however, program latitude and longitude with different kind of values using Faker. And Faker allows us to select a random value for these fields. And in this case, it makes sense to put latitude with a random integer. And the same thing goes for longitude. And now if we make our request, we can see that we have a new location given to our database with random numbers for latitude and longitude that we can then look in our database and see that they have been added, just as we can see right over here. But we still have one problem, and that is this animal ID. The animal ID is something that we know at this point that is fixed, and we read it and we were able to read it from the database. But normally from the outside you cannot read these animal ID values. We have, however, an endpoint in the aggregator that gives us just that. Let's have a look at that endpoint from our IDE. And so if we go to the test requests and we have a look at how do we get the animal list, we can see that the endpoint is accessible via port 8082 and at this URL. That means that if we call the aggregator on this endpoint, we'll get a list of all the animals in our database. And these are exactly these two, Pequeno and Test Pequeno. We want the first one. And so one of the things that is important in Insomnia to do in this case is to get the first animal out of our database. And for that, we will create manually a new request. And this request will have as its URL this one. And then we can try it and see that we get the 2 different animals here. So essentially we need to get the first element of the response and the ID of the first element of the first response. How do we do that in our requests? Let's just first give it a nice name. Let's say that this is settings. Let's call it, instead of new requests, let's say this get animals, for example. And this we can then save like this. And then we can go to our post create location, which is this one, and then say over here that we want to get, that we want to put on this field the response that comes, something that comes out of a raw body of a response. So we need to select it and then say here that we want the request out of get animals. And we already have here a live preview of that request. So that means that we can select precisely what we want over here if we select over here the body attribute. And in the body attribute we can use JSON path. And to do that, we know that we want the first element ID, which should be this one. And as you can see in the live preview, we get the UID for this animal. Now the beautiful thing is that now we are done. We get now still some errors because we removed the double quotes. Remember, the JSON payloads need to be defined with double quotes. If we send this now, we will see that the animal is correct. We got a new random number. Remember that this 29 and this 38 over here, and let's see if we can see that back in the database. If we go over here and then we go to our database in animal locations and refresh, We can see 26 and 38, which means that this is the data that we have just placed in the database, and this request will be a chain request that will first get all the animals from the database, get the first one, use the first animal's ID in our second payload for the post request, and then puts a random location. So this already provides us with some level of manual testing. The first testing that we can see here is that we check the get animals. If it works, then we get a list, and with that list we create a location, and that location is made by using the animal that comes from the previous request. So we are already testing the aggregate to some level and also the listener to some level. And then we also have the info, as we have seen, now is completely tested and returns the listener service v1. But these are only collections. This is created only for users that want to test the application manually. If we want to automate this, we need to make tests, and we can find tests under this tab, and here we can create new test suites. An easy way to create a test suite is only to check if we get a 200, and that's simply by going here to the new test suite, go here to run test. Now everything runs, there's no test of course, but if we do a new test, we can select here a request, for example get info, and we are already testing get info, and if we run it, we see that it runs because it returns a 200, and we can specify inside of it via JavaScript what we want to test for. We can use expectations. This is compatible with Kai, so Kai expectations are pretty much accepted here, and we can use them in any way we want to check our requests regarding payload and regarding statuses, for example. We can also test another request, for example the create request, which we should now be able to get a 200 as well. If we run it, we see that we get a 200. Then we can just assume that a new location has been created or not, but we can check that in the database, of course, right now. So if we now perform a refresh of the database, we see that there's a new entry number 9, with a new latitude and a new longitude. This is all great, and we can also test for the remaining request, and that is the get animals, which means that in this suite, we can also test a different service. So we are testing a bit of the aggregator and a bit of the listener. This is all fine. There is a catch here that I want you to remember. Unfortunately, for this specific situation where we get a dynamic request and other kind of dynamic requests, when we export this data to be used with INSO automatically for our pipelines, they just don't work yet. At least I wasn't be able to get it to work. And I have checked this in the export documents. And the export documents, unfortunately, do not export the capability of using chained requests. So this is the reason why am I using a fixed ID test pequeno, because that is the one that we use in our pipeline in the end. That means that in GitHub Actions, we make tests using a fixed ID animal instead of an animal created with a randomly generated ID. Alright, so this is one way to test the listener. Let's check the aggregator and how could we make changes there for our tests. And I will now delete this document because this is not the document that we want to have a look at. This is just something that I have created now to give you a demo of some possibilities using Insomnia for this particular service. But we want to test another service, and that is the aggregator. So let's have a look at it right now. And so we know at this point how to import a document, how to start a new document in Insomnia. Easy. We need first to get the OpenAPI specification for the particular service that we want to test. So let's go back to our IDE and get the aggregator's OpenAPI specification document. So now we already know how to do this. And so over here, in the aggregator service, what we are interested now in testing is the locations. So we want to simply be able to call the first test suite and create different locations in our database. So that means that the sensor will be sending data to our database, let's say 10, and then we want to test if we see 10 different locations. And to do that, of course, the method that we want to focus on is the list all with all the animal locations. So if we go over here, we find the animal location controller. This is the one where we want to create our specification. Let's do that. And so we can go over here, and here we generate the OpenAPI draft. We can copy, and then here we do a create, import, and then we go to clipboard, and we scan our clipboard content. And then we import it. We see that it has one single request. That is our list of locations. And then finally, we click on import, and we've got a new wildlife safety monitor document, but in this case, it is for the aggregator. Let's open it and see if that makes sense. It does make sense. One thing that we just forgot to do is to correct the location of the URL. That one is very easy. We can just go over here to our test request scratchpad, and then here we can get the aggregator URL, and we can just put it over here. And we don't want, of course, animal in this case, because this one here is the root of our service. Let's test it and see if it works. So we can go over here to the right, and let me just fix this a bit so that we can see it better. See, we can see we already have the small GUI just like we did in the IDE, and then we can click on it and just simply try it out. And if we execute it, we should get a list of the current locations that we have placed in the database, which is great because now we are sure that this works. So let's now create a collection with it. Go over here and generate a collection. It creates the different requests that we need. In this case, we only have one, that's the get location. And if we just go here to manage environments, we can, of course, now create our own base URL variable that we need so that we know where our service is located. So this is the URL of our aggregator service. We can close this one, and now what we should do, just to be sure that we are doing everything right, is just send a request, and there we go. On the right side, we see all of the locations that we need. One thing that we may find interesting also to test here, and this is just to show you how pre-scripting can work for us, is going over here to scripts, and here we can put any kind of script we want to execute before we make our request. Of course, here we are still in the collection. This means that we are only configuring our manual requests. And one particular script that we want to test is the one that I have stored in the repository. So if we go over there and we go to our folder and go to prescript location, we can then copy paste this straight into here. And here we've got all of the script that is going to do something very specific and very easy that you have already seen in other examples throughout this video series. So the first thing that we want to do is to get an animal. So what it does, it gets the animal, then it will get the first ID of that animal. And that first ID of that animal will be used in the second request, which is to create a location. And it will do that over here on this endpoint. When the new location has been added, we want to see that location back. And to see the location back is the actual request here. So prescripting works in the following way. We first execute anything we need to execute. In this case over here, we can use our variables from our environment, and then we can just perform our request. If we run this right now, as it is, we will get an actual location here. We can see that the last location now is 2023, so latitude is 20, longitude is 23, the first two numbers. So let's just send it and see what happens. If we send it, we've got a response, so let's check what's at the end. Now we should expect an extra location to be added. Remember, 2023 and this latitude and longitude, which are the latitude and longitudes that we have placed over here. And as you can see, this one, if you have already memorized it a bit, because we've seen it so often, this is the ID of Pequeno for our execution. It's a random ID. The power of using this JavaScript is very interesting because in one single request, we can test everything that we have seen before in one go and see it working. We can jump from here into making our tests. So let's go into the tests tab and just add a new test suite as we did before, and then run the test for the new request, which is a get location. So what do you think will happen when we run this test? We are going to run the previous request, the get location request, which has a prescripting installed. The prescripting will make a request to the current animals we have, get the last one, post a new location, and then at the end, the actual request will be run, the get all locations, where we will see that the new location will be added. At least this was the behavior that we saw before in the collections. Now, will this happen also when we run this in the tests tab? Let's have a look. We run the tests and we see a 200. Now remember that we've had one last location with static locations. So if that script has been executed, we should be able to see an actual location. Otherwise, we don't see that actual location. Let's see what actually happened when you go here to collection. Now, if I would run this get location right now, it would create an extra location. The danger with that is that we would have something extra in our set of different locations currently available in our database. So what we are going to do, we're going to add a new request with this location and the base URL over here, URL. And one more thing, this underscore here and the dot after that allow us to do some kind of auto-completion, which is very handy. That is just another feature that is an integral part of Insomnia. So let's see now what happens if we run this request. Do we get an actual location or not? Let's have a look. We go all the way down and we see that we only have one extra static location, which was exactly how the system looked like before we ran that test. What this means is that the tests don't run these pre-scripting scripts. At least not the way I have created them. We can go back to tests. In here we see that we can only configure the location. There isn't really a place where we can say that we need to run the pre-scripts. And so the only thing that the tests do is everything automated. And unfortunately that pre-scripting doesn't work. So we already know two things. Pre-scripting here in the tests don't work. And the automated chain test requests using the dynamic insertion of values also doesn't work. So what this tells us is that everything that runs in tests has to be well defined in the collection, and everything that's dynamic probably won't work. And we need to check if everything that's dynamic works. As a heads up, the random integers do work, and that means that we can use them in our test setup for the Git Actions pipeline. So now we can go to the main page and delete this one also. Alright, so we've got all our different requests over here, and now it would be interesting to be able to run these tests against our cluster in an automated way. But first, let's have a look at how the tests actually look like to be able to run them within the virtual environment of Git Actions. So the first thing we want to look at is the first version that I had created of the listener. Here we can go straight into collections. We don't have any scripts here anymore. And if we go to body of the create location, we see that we still have a chained response. So this test will fail, but we will check it out shortly in the pipeline if that works or not. Info should work in any case here. We have seen that before. And the get latest animal should also work because it doesn't have any scripts and it doesn't have any particular dependency and it doesn't have any body. The whole test suite will fail simply because of that simple request to add another location to our database. If we go back now and we check out the static listener, now this one is a different story because this one does a post request, but the body is fixed. So that animal ID is the animal ID of our fixed animal that we created the database, the test Pequeno animal. Let's have a look if that matches. 520 should match to what we have in the database, which is 520. Alright, so this is a test suite that will work because it will find the last animal, it will be able to send the location on behalf of the test Pequeno, and it will get the information of the current version of the service. Then we find the aggregator. The aggregator test has a get for the location, a get for the animals, and it has a get pre-scripting. This pre-request is exactly the same as we have seen before, and it is here so that we see when we run this from the command line that this doesn't work. So we can see in the test that all of this will be tested, all locations, the call get, and the prescript locations. From within, this will all work, except that now the quantities are different, because instead of having one animal, I actually have two, so I need to change this to 2, and now it works, it passes. So we get all locations. It should be green if we have 10 locations. It should probably fail as well. I think it's just pure luck that we have 10. And the second one is simply the prescript locations, which of course should have 10 as well. And in this case it has 10 because we do have 10 locations, and we can check that in the get location over here, the one without prescripting. All right, so we can send this one, and we can see that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we've got, curiously, 10 locations. This is the setup that we have in Insomnia. One thing is, when we are logged into Insomnia, that means that something happens in our system that allows the system to know that we are connected to Insomnia and that we want to run all of these tests. To run these tests, we only need to run a specific command, and we can look at it in the GitHub Actions file, where we can already have an idea of how the pipelines are set up. But for now, the thing that we are interested in is how do we start tests, and that is with the script insomnia start test pod. And this test pod is another pod that we need to perform our tests automatically. I will explain in a minute why do we need a pod for it, but locally we don't need it because we know what localhost is. So let's have a look at our test pod, and that is the one over here. And if we go to the make file, we can see that it runs an entry point that has this. And what we need at this point is just this, inso run test. If we run inso run test, we'll be able to first choose the test suite that we want to start. And if we choose the first one, the static listener, it will run successfully because it is only creating an extra location. If we run the second suite, which is the non-static listener, we will have a problem. If we run the non-static version, it means that we are going to try to get our animal from the aggregator service. We have seen before that this doesn't work, and in fact, if we now run it, we see that it doesn't work. The reason being is that it has no understanding of that request, and therefore it doesn't perform it, we don't get the ID, and so it cannot post a new location. And so the 200 request will fail. If we now run the last, which is the aggregated test suite, now I think all the tests will fail because all the locations have changed. There are more than 10 locations, and plus the pre-scripting is not working. Let's have a look at what happens. There. So at this point, there are 13 locations there. That is because in between I made a test request, and so we have 13. And we see that the call to prescript endpoint also failed. And the reason for that is that we still have 13 locations. So what this tells us is that prescripting didn't work, because otherwise we would have a fail as well, but a 14 locations fail, not 13. And so prescripting doesn't work, and chained requests don't work as well. But random does work, and that is what we saw in the previous successful results. Now, we can also make these now work because we know that we have 13 locations now in the database. And so it's very easy. We can just go over here to the aggregator. And in the aggregator, we can just go here to the tests. And wherever we test for 10, we will now test for 13. And here as well. No, not here because we test for 2 animals. And here we test 13. Okay, so now let's run this from the command line, and if we run these, they should all be successful. And the pre-scripting also works, but that's because we cheated. Pre-scripting here, this should have been a 14 and not a 13. And so if we run now, this will fail. Here we've got 2 different kinds of requests that we cannot perform in the pipeline. So this is why it was necessary for me to make this all static. While this is all very interesting, it is also very important that we get an idea of how do we put this in the pipeline. As we have seen before, and if you paid attention to this one over here, you would have realized that I'm making these specific requests to invoke specific test suites. So here I'm opening this document, and I'm opening the first suite that comes in the list. We only have one suite, so we can just do this echo, so we don't have to choose it automatically. And here also, the first suite from this document. The first one will launch 10 times to create 10 locations, and the second one will launch only once to test for 2 animals and that the 10 locations exist in our database. As simple as that. But before we get to here, which is the end of how this was implemented in GitHub Actions, we need to think, how do we run this in Git Actions? Because Git Actions runs on a virtual environment that has no concept or little concept of what a localhost is. In some of these environments, we can't even get the machine name. But this is always a problem. In these virtual environments, we cannot get the local host, we cannot get a local machine. So how are we going to perform our tests if we need to access endpoints? Well, the answer is to get a containerized environment within the virtual environment so that we can access our endpoints using localhost or the name of the machines themselves. And this is why these tests needed to be integrated in a container, which will then run in a pod in our Kubernetes cluster. And the way to do that is actually very simple. The only thing though is that we will need to replace every single text that refers to localhost to the matching service. But before we get to there, the first thing that we need to do is to export our documents in the correct format. I chose JSON, you can choose YAML if you prefer, but the idea is that we can use these files and then make sure to point them out when we run the test commands. If you have noticed, now in the pipeline we didn't specify any test suite, and we also did not specify any single particular file. In the pipeline though, we need to do that because in the pipeline we do not have Insomnia installed and we have not logged in. So, having said that, let's now have a look how to export documents in Insomnia. So we go back to our Insomnia desktop API, we go back to the home page, and now we have 3 different documents. These 3 different documents have been created for the example, but the ones that we are mostly interested in are the static listener and the aggregator. If we go to the aggregator, there is an object here at the top right corner of these documents, over here, where we can simply select export. And in export, we can choose the request that we want to export, and then we can choose the format that we want to export them with. We can choose these 3. The one that worked for this project was a JSON file. So we can do that and we can be done with it. And then we can choose where do we want to save it. We can just save it in our own particular folder. We can save like in exports folder. And in this exports folder, we can just save our JSON files. So this one was for this aggregator. And the other one, let's choose the static listener to export as well. All the requests, and then we export them to a JSON format file over here. Notice that the Insomnia files are saved as Insomnia and the current date by default, so that means that you may overwrite the previous file. So in this case we just say aggregator, for example. Now that we have this, we can go to our browser and go to documents where we save this, go here to exports, and then here we finally have these files that we can now have a look at what's inside of them. These are very readable files. So if we just open these files in IntelliJ, we can select both of them and just open them up in IntelliJ over here, and we format them, then we can read the contents. We're not going to use these files. This is just for an example. So here in these files we find all of these definitions, and if you notice we have all of these local hosts everywhere, and especially the definition of our URL variable. So we've got here localhost, and then for example over here we've got the base URL, and if we look for base URL, then we are going to see in one of the reference to it that it defines its value as being localhost 8080 app v1 listener. We know that our listener is running on localhost, but here's the interesting part. If we run it in a containerized environment, it's no longer localhost. Then the machine has a name that Kubernetes gives it to it. And here we need to make a small review of how domain names are created inside a Kubernetes cluster. Let's have a look at that. For example, if we look at this same file that has already been created and already running in GitHub Actions inside the test project, which is this one over here. If we go here to Insomnia, we can find insomnia.json. This one has already been created, and we also have Insomnia Listener. If we look at the Insomnia Listener, for example, we can see that the aggregator has a domain name like this: WLSM aggregator deployment, followed by WLSM namespace, SVC cluster local 8082. By default, this is how we access the containers inside the Kubernetes cluster. The first element is the name of the service. Let's have a look at it. In the aggregator, we will find in the deployment file, we will find that the name of the service is WLSM aggregator deployment. And so that's the service name. Then we put in the namespace. So dot the namespace, which is WLSM namespace. We can also check it over here. It is created over here on the first segment of this deployment script. And then finally, at the end, we just use SVC cluster local. Then we define the port 8082 and then the rest of the URL path. And this is valid also for the listener. So if we look for listener over here, we should find that we also have the domain or the listener running container inside the pod that has this URL as the address to access the listener endpoints. After we make this replacement, then it becomes very easy because now the files are ready to be executed in the pipeline. And the way this works is by the usage of a Docker file. And the Docker file is located right over here inside the Insomnia test folder. And here we can see that we are creating a Docker container from an Ubuntu image, and we are installing some very necessary command line applications. The first one is curl, then we install also sudo. And with this, then we are allowed to install a couple of things that are very important. But let's go one by one. The next two commands inside our Docker file are copy. So we are going to copy the Insomnia installation script and the Inso installation script. In order for this to run smoothly, we want to avoid any kind of warnings that we may have when we run Inso. Here is something that I learned. When Inso starts with its latest version, what happens is that it will complain that these libraries aren't available. So I decided to install them in a container before we run the tests. Finally, we run the installation scripts for Insomnia and for Inso. And the reason for doing that right over here is to avoid having to reinstall everything when we restart the container. It is a general good practice. And then finally, we copy the files that have our test definitions, the Insomnia file and the Insomnia listener file. The first file is about the aggregator, and the second one, of course, as the name explains, is about the listener tests. So these two will be run every time we start the container, and the container will not stay running. The container will only just run the entry point, which is located right over here, and it will run these two commands. The first command is the Insomnia listener. It will run it 10 times to create 10 different locations, and finally it will run the aggregator test that will test for 10 different locations and check that there are two and only two animals in the database: our Pequeno created with a randomly generated ID and our test Pequeno with a fixed UUID. Finally, the way to run these tests is very easy. In the GitHub workflows actions definitions, we've got one particular file that is this monitor Insomnia file, where we have defined everything that we need in order to be able to run the test. The first thing that this does is install all the necessary command line applications that we will need. Then it will start our cluster just as we did locally. Then it will check the status of the pods and print them out to the console, only for debugging purposes. And then it will start the test and finally show the results. Let's have a look at the start test. The start test is located in the make file right over here. And what this does, it goes into the Insomnia test, it builds a new image, and finally, once the image is created, it applies the deploy Kubernetes template file, and then finally it will wait for everything to be completed or running. In this case, the idea is to wait for the Insomnium test to complete. Then we've got the show results, and in the show results, the only thing that will happen is show the results of the execution, which is a printout of the logout of the console, and that is done over here inside the WLSM Insomnia test folder in the show results script over here, which tests for the different possible terminal states of this pod. The script itself does not check for this specific pod, it tests for the last pod, and it's obviously this is the last pod that it's running because this is the last one that we've started, so it sorts everything by start date. And so the last pod is checked for status succeeded, failed, or error. And at the end, if the result is anything other than completed, then we report a fail to the running execution in the GitHub Actions, or we just let it continue, and that will be reported as a success. But we can also run this locally. So let's try just that. Our application is already running, but it is now filled with more than 10 locations, and we want to start from scratch. So to do that, we'll just go here to the database and just drop everything. So delete rows and just commit them. So there are no more animal locations in our database. And now let's just run our pod and see what happens. So this means that we have to run make Insomnia start test pod. So now it will start the container, and at the end we expect to see only success results in the logs. Now that the execution has been complete, let's have a look at the results, and this mimics what we see in the GitHub Actions that I will show you in a minute. So now we issue command make show results. And we can see now that at the top, we first ran the static listener, which is about making the requests to our listener 10 times. And we can see that we've got a bunch of them. I can assure you that these are 10. After finishing the listener tests, we move on to the aggregator tests. And at this point, there will be 10 records in the database that then this test will say everything is okay, because we are waiting for 10 locations in all of the 3 tests. And even the pre-script, we know that no script has run, and therefore it will only have 10 locations when we run the endpoint that we have configured to have pre-scripting. But the final test will be to check in the database and see if we do actually have 10 records over there. This is an easy thing to do, just opening the database, because we do have the open ports. Remember that? We've made the port forwarding open and available. Now we can check the database and we see that we have 10 records. And these are records that have been created with our tests, which will also happen in GitHub Actions. And if you noticed, latitude and longitude have been created with random numbers using the faker option of Insomnia. But the rest didn't work. What's left for me to do in this video series is just to show you the GitHub Action pipelines in the project Wildlife Safety Monitor. Let's have a look. If we go to Wildlife Safety Monitor and we go to Actions, we will find the last Insomnia action, which is this one that it's called Wildlife Safety Monitor Insomnia. So let's open it. We see that everything ran perfectly and that we've got a green job. Let's open it. Everything seems to have run okay, but let's have a look at the show results, which is the important part that we just saw in our local machine, but now in GitHub. If we show the results, we have exactly the same. 10 calls to the listener service. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then the last suite, the aggregator suite, where we check for the existence of 10 locations using the pre-scripting request and the non-pre-scripting request. Either of them doesn't run as any scripting request. And we also run the test that checks for how many animals are in the database, in this case 2, and they are all successful. This is the way I have created a project using Kubernetes, and I tested it using Insomnia in a pipeline-driven environment using GitHub Actions. The important takes about this. This experiment runs now correctly, and every time I do something with my project, I know that these tests are going to run together. It will test the flow from the listener to the collector to the database and from the aggregator to the database. These are very important steps, which seem very simple, but they are a chain of events that also have an event publisher in the middle and also use a Hazelcast cache, even though it's just to put some data in it and never use it again. But still, it goes through all of that life cycle. But this was all implemented open source. That means that when exploring this open source, a lot of the features might not be available. Think of, for example, what we just saw with pre-scripting and with chained requests. But having it open source doesn't really prevent us from using Inso and Insomnia in our pipelines to perform tests for our applications. I see this kind of testing important. It is a kind of chain test mixed with end-to-end testing. And it gives us more assurance that our project, at least logically, does what it has to do.
As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video.